The James Webb Telescope has recently sent a big warning to Earth from the exoplanet Proxima B, which is getting closer and closer. Each new image makes us question ourselves more. The authorities are terrified. Every photograph of this distant planet fills us with doubts. They are worrying pieces of a growing enigma about a hostile planet near Earth. What if we have a neighboring alien planet that seeks to destroy us? Join us as to discover the terrible entities that Proxima B hides millions of kilometers away. A dream or a nightmare? Where are the aliens? This question keeps coming up. Honestly, the universe doesn't make it easy to find an answer. We continue to use our best technology, like the James Webb Space Telescope, in the hope of capturing something, any hint of life beyond Earth. But let's be real. Each new image and data mainly reminds us of how little we know. We're told these discoveries could be revolutionary. Understanding a distant planet like Proxima B could redefine our place in the cosmos. However, while astrophysicist experts find this exciting, for most people it's just more space news that doesn't really affect their lives. It's another small step in a huge ongoing quest that seems to raise more and more questions than answers. Despite its power, the JWST cannot reveal much to us. We've learned things like the universe is bigger than we thought, which is interesting, but then what? In terms of practical implications, the distance between scientific discoveries and their everyday relevance can seem as immense as the universe itself. We return to Proxima B. Discovered in 2013 due to its gravitational interaction with its star. For scientists, it was like finding a new neighbor in the cosmos. This planet is only slightly larger than Earth and completes one orbit around its star every 11 days. The idea of another world so close to our own is scientifically exciting, but it's difficult for most people to connect with a place that's 4.5 light years away. Imagine being in Proxima B. You would see its star, Proxima Centauri, as a large, faint red light in the sky, much cooler than our Sun. The planet orbits its star so quickly that its year lasts over a week. One side of the planet is always facing the star, receiving constant daylight, while the other side is in perpetual night. It seems like something out of a fairy tale, but the reality of living there would be brutal. The proximity to its star means that any water could evaporate on the light side and freeze on the dark side. In addition, Proxima Centauri is an active star that emits strong calls of radiation. Not exactly the neighborhood one would want to move to. The enthusiasm for finding life beyond Earth really took off in the late 2020, when scientists detected an unusual signal from the Alpha Centauri system, home of Proxima Centauri. The signal had a unique frequency of 982.551 Hz, capturing the world's attention. Recently, the James Webb Space Telescope sparked even more interest by suggesting that Proxima B might have water vapor in its atmosphere. This discovery is crucial since water is essential for life as we know it. To better understand the amount of water in Proxima B, scientists are using all the advanced techniques available. Spectroscopy, a method that allows the gases around Proxima B to be identified, acts as a high-tech research tool. Atmospheric modeling, another technique, involves creating computation simulation of Proxima B's atmosphere. These simulations help scientists make assumptions about the atmosphere, similar to how paleontologists use dinosaurs' bones to imagine what it might look like. These scientific methods have revealed gases such as oxygen, methane, and carbon dioxide around Proxima B, which are essential for life. They also allow scientists to run experiments with different scenarios in their computational models, like children playing with ideas at a science fair project. While these tools are revealing more about Proxima B's atmosphere, they also remind us of the incredible variety of life forms on Earth. For example, extremophiles are tiny organisms that live in the most extreme conditions on our planet. They can inhabit boiling hot springs, acidic lakes near volcanoes, and even the frigid cold of Antarctica. These organisms demonstrate how life can adapt and thrive in conditions that we previously considered impossible for survival. The research for life on Proxima B poses enormous challenges. However, the challenge of proving that there is life on Proxima B is daunting. Scientists not only have to overcome intense space radiation, but they also need advanced technological equipment capable of tackling this task. The distances to travel to reach Proxima B are enormous. Ideas like solar sails, ion propulsion, and even theoretical concepts like warp drives offer exciting possibilities for future space travel. These technologies could reduce the time needed to travel between stars, opening new opportunities for exploration and discovery. However, these technologies are still in the early stages of development and require research and testing before they can be used in real missions. While thinking about these future possibilities is exciting, we must be realistic. The path to discovery of life on Proxima B is full of technological and scientific obstacles. We need to continue improving our technology and our understanding of the universe. Only then can we hope to explore distant worlds like Proxima B and possibly find signs of life on them. Pursuing these goals not only satisfies our curiosity, but also pushes the boundaries of what humanity can achieve by reaching for the stars. When we think about the long journey to Proxima Centauri, our closest star system, the idea of encountering aliens seems less like a fantasy and more like a real possibility. This shift from being just a story in a book to something we could actually achieve has been taken seriously by groups like Breakthrough Initiatives. They are working hard to reduce a journey that would take thousands of years to just a few decades. However, achieving these ambitious goals faces the harsh reality of our current technology. Trying to accelerate a spaceship to near light speed with the technology we have today feels almost impossible, like trying to solve a very difficult puzzle in the dark. One suggested solution is to use adaptive optics, where smaller lasers on satellites would continuously monitor the atmosphere and adjust for any disturbances. This would help powerful lasers on Earth keep their focus on spacecraft as it flies through space. This laser technique would require an enormous amount of energy, equivalent to the total energy used by the entire United States, and would only work for a short period of time. Imagine installing 100 million lasers over a large area, all to power a small 10-meter wide spacecraft at 20% speed of light. However, getting to the Alpha Centauri system doesn't just involve solving technical challenges. There are also natural obstacles: the sun's gravity, space rock fragments, and the immense distance present significant risks. Even communicating with the spacecraft would be like sending messages through time, as it would take approximately 4 years for a message to travel from Earth to the spacecraft. Proxima B is an Earth-like planet orbiting the closest star to our solar system. What a coincidence! Although conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These super habitable planets, as Michio Kaku calls them, are fascinating and pose exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these super habitable planets may offer. He firmly believes in the possibility of achieving immortality and, furthermore, aspires that in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in places in case of something catastrophic happens on Earth, such as meteorite impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first steps to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets, or even better planets called superhabitable planets, that have even greater potential to harbor life than our own home. The term superhabitable planet was proposed in 2014 by Reid Heller and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Superhabitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that the Earth, as we only known planet with life, meets the psychochemical parameters necessary for the development of life. These parameters are key to life as we know it, and one of the essential elements is the presence of liquid water. It is for this reason that we search for exoplanets similar to Earth, in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world could also be a mood with a richer range of flora or fauna compared to our own planet. Such a world would be shown as a higher degree of environment conducive to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of superhabitable planets can be complicated to convey as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, research needs to explore indicators that may reveal the existence of superhabitable worlds. Among the promising targets, Alpha Centauri B has emerged. Alpha Centauri B is part of the closest star system to our planet, which makes its potential exciting. However, so far, no planets have been confirmed to be present in this system, much less superhabitable planets. While there was a possible detection in 2012, it was refuted in 2015. Therefore, we do not yet know of any worlds in Alpha Centauri B. However, its neighbors, such as Proxima Centauri, are of special interest. Proxima Centauri is a red dwarf located only 4.2 light-years from Earth, making it an intriguing candidate to host not only habitable planets, but also possible superhabitable planets. Within the Proxima Centauri system, an exoplanet called Proxima Centauri B has been identified as residing in the red dwarf's habitable zone, along with other contending candidates such as Proxima C and Proxima D. Proxima Centauri B is one of the closest known exoplanets to our solar system, which has led to the question of whether this planet could be habitable. However, there are significant obstacles to life thriving here. Several variables complicate the habitability of Proxima Centauri B, such as the activity of the host star and tidal locking phenomena. The light emitted by Proxima Centauri is comparatively redder, which could reduce the interactions with certain organic compounds and decrease ozone production in the planet's atmosphere. This in turn could generate elevated levels of UV radiation harmful to life. In addition, Proxima Centauri B's orbit may be eccentric, which means that in certain parts of its journey, the planet could temporarily fall outside the habitable zone. These fluctuations could negatively affect its habitability potential. Another factor to consider is the presence of carbon monoxide in the planet's atmosphere. If these gases accumulate in excessive amounts, they could become toxic to living organisms. On the other hand, if Proxima Centauri B were to host oceans, higher oxygen concentrations could have a positive effect on the evolution of complex organisms. Tidal forces, due to tidal locking on this planet, would generate periodic cycles of flooding and drying in coastal landscapes. These cycles could trigger chemical reactions conducive to the development of life and promote the emergence of biological rhythms similar to the natural cycles we observe on Earth. In addition, Similar cycles of flooding and drying would facilitate the mixing and distribution of nutrients in the oceans, stimulating periodic expansions of marine organisms, akin to what we know as red tides on our planet. It is important to mention that although red dwarfs, such as Proxima Centauri, are exceptionally long-lived compared to our Sun, their radiation is not conductive to photosynthesis as we know it. However, Proxima Centauri b might be able to support a different type of photosynthesis called anoxygenic, although its possibility is not yet fully confirmed. A 2017 study suggested that photosynthesis-based ecosystem on this planet could be about 20 times more productive than the one we find on Earth. The stability of the planet's atmosphere is a major challenge to its habitability. Even before Proxima b was discovered, researchers had been actively searching for exoplanets in the vicinity of Proxima Centauri. In the research conducted in 2008 and 2009, the lack of larger-than-Earth exoplanets in the habitable zone around dwarf stars, which include Proxima Centauri, was noted. Although these stars have on average 1 or 2 planets, only 20% to 40% of red dwarfs harbor planets in their habitable zones. Therefore, our search for a habitable planet in the Alpha Centauri system has not yielded many results so far. While it makes sense to search for exoplanets in the Alpha Centauri system, since it is the closest star system to our home, there are many other options in the vast expanse of our galaxy. So far, more than 5,000 exoplanets have been confirmed, and there are countless candidates awaiting new observations for verification. James' achievements on the Webb have exceeded our expectations, consisting of a 6.5-meter mirror, a sun shield the size of a tennis court, and a complex array of instruments cooled to temperatures near absolute zero. The telescope observes the sky in infrared radiation, revealing details of the universe just after its birth 13.8 billion years ago. It captured images of stars born in clouds of dust and collects faint lights from the deepest of the universe, exploring its darkest corners. The infrared instruments of the space-time network are also useful for studying strange and bizarre worlds. In particular, James Webb has focused on Proxima B, capturing the sharpest image of our closest known neighboring exoplanet. What's fascinating is that what it has revealed goes beyond our expectations. In January 2024, we have reached a remarkable milestone in our understanding of the universe. For millennia, humans have observed the sky, wondering about points of light in apparent infinity. Just 3 decades ago, we began to discover planets orbiting other stars through a variety of methods. Now, 55 confirmed exoplanets and 10,000 additional candidates. We are in a new era of astronomy, exploring fascinating and diverse worlds beyond our own solar system. Planet formation exhibits remarkable diversity, determined by a number of factors including the chemical composition, geological activity, and atmospheres. When findings point to the presence of worlds with chemical elements, even superficially related to life, the discoveries are significant, providing answers to some of our questions about the cosmos. However, deeper questions remain. In this context, the mission of the James Webb Space Telescope is focused on exploring the atmospheres of exoplanets for signs of life in other corners of the universe. Although James Webb is an infrared telescope, which raises the question of its suitability for studying exoplanets, it will use the transit method for this purpose. This method involves observing the light from a star as a transiting planet passes between the star and us. Collaboration with ground-based telescopes will complement this research by allowing measurements of the mass of planets using the radio velocity technique, which detects the slight wobble induced by a planet's gravitational tug. In addition, James Webb will perform spectroscopy of planetary atmospheres and carry coronagraphs to obtain direct images of nearby exoplanets. Although these images may appear to be simple points of light, their detailed analysis will reveal valuable information, such as color variations that may indicate seasonal or rotational differences in vegetation. Spectroscopy, which involves measuring the intensity of light at different wavelengths, is fundamental to unraveling the atmospheric compositions of exoplanets. When a planet transits in front of a star, starlight passes through its atmosphere, and the elements and compounds present in the atmosphere absorb light at characteristic wavelengths. This absorption is reflected in the observed spectrum, making it possible to identify the presence of elements such as sodium, methane, or water. An infrared telescope is essential for characterizing the atmospheres of these exoplanets because many of the gases relevant to the search for life, such as water and carbon dioxide, emit and absorb light in the infrared range. In addition, this wavelength provides valuable information about the temperature and chemical composition of the atmospheres, which contributes significantly to our understanding of the habitability of these distant worlds. Observation in the infrared spectrum offers the advantage that the molecules present in the atmospheres of exoplanets exhibit a wide range of spectral characteristics. The ultimate goal is to discover a planet with an Earth-like atmosphere, and in this effort, to find an Earth 2.0, the James Webb Telescope has turned its attention to Proxima B. This enigmatic exoplanet, located light years away, is the closest known neighbor. Proxima Centauri B is a super-Earth orbiting an M-type star with a mass approximately 1.27 times that of Earth and an orbital period of 11.2 days. This planet lies at a distance of about 0.085 astronomical units from its star within the habitable zone. However, the extreme intense ultraviolet radiation it receives from its star poses challenges to habitability, as this radiation can erode the atmosphere and compromise the presence of elements essential for life, such as oxygen and nitrogen. The habitability of a planet depends not only on its location in the habitable zone, but also on the ability of its atmosphere to maintain conditions suitable for life, such as climate regulation, radiation protection, and preservation of necessary chemical components. In addition to Proxima B, James Webb is also interested in other exoplanets, such as WASP 107b and the Wandering Worlds of the Orion Nebula, which challenge our conventional conceptions of planetary formation. These recent discoveries have opened up new questions about the formation and diversity of objects in the universe, challenging our existing theories and stimulating continued explorations of the cosmos. We were on the lookout for astronomical tiny objects, and we have found them, even as small as half of mass of Jupiter, floating freely in space, unbound to any star. Physics tells us that objects of such a small scale should not exist, but we seem to have defied those laws. These bodies, which are technically not planets, have been dubbed Jupiter mass binary objects because several of those identified come in pairs. Although these two jumbos are 2 of 1 million years old, which is very young in astronomical terms, their first surface temperatures reaching a scoring 1,000 degrees Celsius, although they will eventually cool. Although these objects may exhibit interesting atmospheric features, such as the presence of steam and methane, they are not considered capable of harboring extraterrestrial life, as their surfaces could not sustain liquid water, even during their brief period of moderate temperature. These observations have focused on the Orion Nebula, a region of massive star formation located 1,344 light-years away from Earth. This nebula, visible to the naked eye as a fuzzy star in the sword of the constellation Orion, is a celestial spectacle filled with clouds of dust and gas, where explosions and gravitational collapses occurred and give rise to formation of stars and other celestial objects. The most recent findings have puzzled astronomers, especially the presence of numerous pairs of Jupiter-sized objects. The question of how these objects can be flown out of a star's orbit in chaotic interactions and then rejoined remains an enigma. Even experts like Professor Matthew Bates, head of astrophysics at the University of Exeter, acknowledged that they have no definitive answer to this anomaly. It seems that our current theories are not sufficient to fully explain these new findings. There is an unknown mechanism that is shaping these objects, something we have not yet considered. This type of discovery is quite unusual and challenges us in our understanding of star formation, an area we thought we understood quite well. It is a surprising result from which we can learn more about. Let us know what you think in the comments box. If you liked the video, remember to like it, share it so it reaches more people, and subscribe so you don't miss out on more content like this.